In our lives, in our work, we're constantly staring at a ridiculous number of choices. But what if one of those choices leads to a dead end, while another one leads to a total breakthrough? Well, in the world of AI, that isn't just a puzzle, it's a huge challenge. So today, we're going to explore a really clever technique that basically uses teamwork to find the best path forward.
This right here is the big question, isn't it? It is so easy to settle for a solution that just seems, good enough. But what if the absolute best solution is just around the corner, totally hidden from view? This is a classic problem in computer science, and it's exactly where our journey is going to start. Okay, so to find the right solution, we first need to really understand the trap. The main problem is just getting stuck. See, algorithms, kind of like us, can be a little short-sighted. They might choose a path that looks amazing right now, but it ultimately leads nowhere.
To make this super clear, let's use an analogy. Picture this. You are a mountaineer. Your one and only goal is to get to the highest peak in the entire range. But here's the catch. It's incredibly foggy. You can only see like a few feet in front of you. How in the world do you decide which way to go?
Well, this brings us to a really simple but kind of flawed strategy. It's often called the hill climbing algorithm. For our story, just think of this as our lone climber trying to find the summit all by themselves with a very basic plan.
The logic seems pretty solid, right? I mean, if you want to get to the highest point, you should always be moving up. From wherever you're standing, you just look at all the possible next steps and you pick the one that takes you highest. Simple. What could possibly go wrong? Well, here's what goes wrong. Our climber gets stuck on what's called a local maximum. They reach a little peak, and every single direction from that spot is downhill. So from their limited, foggy perspective, they think they've done it. They've succeeded. But in reality, the true highest peak, the global maximum, is way over on another mountain. They've accidentally settled for a tiny foothill.
And this is the perfect example of the good enough trap. The lone climber plants their flag thinking they've won, completely oblivious to the fact that a much bigger prize was out there. This exact limitation is what more advanced algorithms were built to overcome.
So if one climber gets stuck that easily, what's the answer? Well, it's actually deceptively simple. Don't send just one climber, send a whole team. And that is the core idea that makes local beam search so powerful.
Let's break down the difference. The lone climber, hill climbing, tracks just one single path. That's why it gets stuck so easily on those little peaks, and it has no memory of any other options it might have passed by. But the team approach, local beam search, tracks multiple paths all at the same time. And crucially, they share information, which helps them avoid those small peaks and lets them focus only on the very best options found by the entire team so far.
Okay, so we know a team is better. We get it. But how does this team actually coordinate? How does it all work? Let's dig into the actual mechanics of the local beam search algorithm.
So everything really revolves around one critical variable, K. Now, it's technically called the beam width, but honestly, it's way easier to just think of it as your team size. If K is 5, you've got 5 climbers. If K is 100, you've got 100 climbers. This number K defines how many paths you're exploring at any given time.
And this lays out the process perfectly. First, you start with your K climbers just scattered randomly on the mountain. Then, in step 2, every single one of them looks around and generates a list of all the possible next steps they could take. Now, step 3 is where the magic happens. You take all of those potential steps from all the climbers, throw them into one big pool, and you only pick the best K options out of that entire collection. Finally, the whole team abandons their old spots and move to these new top K locations. And you just repeat that over and over.
So the most important thing to get here is this. It is not a competition. If one climber just happens to stumble upon a fantastic, steep path upward, the algorithm might decide that all 5 climbers should immediately move to that area to explore it more. The individual climbers are just scouts. It's the collective beam of the search that intelligently moves across the map. It's pure, efficient collaboration.
Okay, this all sounds great with our foggy mountain analogy, but where does it actually show up in the real world? Let's take a look at how this algorithm is powering technology that, I guarantee, a lot of us use every single day.
The applications for this are just everywhere, in machine translation, like Google Translate. Instead of just guessing one sentence, the algorithm keeps track of the K most likely translations as it builds the sentence. Same for speech recognition on your phone. It's considering the K most probable sentences you might have said, not just the first one it hears. From robotics pathfinding to optimizing crazy complex factory schedules, it's all about using that team-based approach to find a great solution fast.
So why do this? I mean, why not just check every single possible path to guarantee you find the absolute best one? Well, because in most real-world problems, that could literally take billions of years. Local beam search is this beautiful, pragmatic compromise. It's not guaranteed to find the 100% perfect solution, but it is extremely good at finding a fantastic solution in a totally reasonable amount of time by smartly focusing its energy on the most promising options.
And that kind of leaves us with a bigger question, one that goes way beyond AI. This algorithm's logic really mirrors a dilemma we all face, right? Whether it's in our careers or our projects or just daily decisions, we have a limited beam width. We only have so much attention and energy. Constantly searching for the absolute single best choice can just lead to paralysis. But a focused, team-like approach, that can help us find an excellent path forward. Kind of makes you wonder, doesn't it?